My name is Varshni. I am from SRIT, Computer Science and Engineering branch. Now I am going to say about Lagrange's method of undetermined multipliers. Introduction for Lagrange's method of undetermined multipliers. Used to find maximum or minimum values of a function. It is applied when constraints are given. It is an important method in calculus. Definition for Lagrange's method of undetermined multipliers. Let f of x comma y be the function to be optimized. Let g of x comma y is equals to 0 be the constraint. Then gradient of f is equals to lambda of gradient g. Lambda is called Lagrange multiplier. Basic concept of Lagrange's method of undetermined multipliers. At extreme points, gradients of f and g are parallel. Introduces an unknown constant lambda. Constraint and functions are combined. Conditions for Lagrange's method of undetermined multipliers. Functions must be continuous. Partial derivatives should exist. Use it for equality constraints. Steps involved in Lagrange's method of undetermined multipliers. Write the function f of x comma y. Write the constraint g of x comma y is equals to 0. From equations, gradient f is equals to lambda gradient g. Solve for x comma y comma lambda. Examples for Lagrange's method of undetermined multipliers. Find extrema of f of x comma y is equals to x square plus y square subject to the constraint x plus y is equals to 10. Steps to solve Lagrange's method of undetermined multipliers. Define functions. Identify your function to optimize f of x comma y comma z and your constraint function g of x comma y comma z is equals to k, or g of x comma y comma z minus k is equals to 0. From the Lagrangian, create the new function L of x comma y comma z comma lambda is equals to f of x comma y comma z plus lambda of k minus g of x comma y comma z. Find partial derivatives. Calculate the partial derivatives of L with respect to all variables x comma y comma lambda. Set derivatives to 0. Set all partial derivatives to 0 to get a system of equation. Dou L by dou x is equals to 0. That gives dou f by dou x plus lambda dou g by dou x is equals to 0. Or similar, dou L by dou y is equals to 0. That gives dou f by dou y plus lambda dou g by dou y is equals to 0. Dou L by dou z is equals to 0. That gives dou f by dou z plus lambda dou g by dou z is equals to 0. Dou L by dou lambda is equals to 0. That gives k minus g of x comma y comma z is equals to 0. This just recovers the original constraint. Solve the system. Solve this equation simultaneously for x, y, z and lambda to find critical points. Test for extrema. Plug the x, y, z values back into the original function f to find the maximum or minimum value. Further analysis, like the second derivative test, might be needed to confirm if it's a maximum or minimum value, as the method finds stationary points. Applications for Lagrange's method of undetermined multipliers. Engineering design problems, economic, cost and profit optimization, physics and mathematics. Conclusion for Lagrange's method of undetermined multipliers. Simple and systematic method, useful for constraint optimization, important topic in calculus. Thank you.